You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everyone. My name is Bob Keane. I'm the editor-in-chief of the internationally renowned journal Fire Ecology. As most of you know, Fire Ecology is published by Springer Nature and overseen by the Association for Fire Ecology. It's a well sought out venture, and we really appreciate Springer Nature's efforts to make this journal a really great journal. And the reason it's a great journal is because of papers like the one we're going to talk about today. The title is Drone-Based Multispectral Photogrammetric Point Clouds Classify Fire Severity at Different Canopy strata. And today we have the senior author of that paper, Jonathan Batchelor, with us. Jonathan, hello, and can you introduce yourself?
Thanks so much for the opportunity. I'm Jonathan Batchelor. All of this research was conducted as part of my PhD at the University of Washington, where I was part of the Remote Sensing and Geospatial Analysis Lab. After finishing the PhD, I stayed on at University of Washington in the Pacific Wildland Fire Sciences Laboratory, working on a project focusing on assessing wildfire treatment outcomes. Most recently, as of like a few weeks ago, I started a new role as assistant teaching professor at the University of Montana. So I made a transition to a new institution, and I'll be teaching GIS and work here, and still focusing on fire science, geospatial modeling, and ecological monitoring.
Well, welcome aboard the Fire Ecology Chats train, and welcome to Missoula. Good to see you. Jonathan, what prompted you to do the study? What was the reason?
Well, most traditional methods for assessing fire severity from a remote sensing perspective rely heavily on satellite imagery, which is, inherently two-dimensional, often only limited to like 30-meter resolution. And these methods, we assign severity at a pixel level. So this pixel is this severity, and usually based on spectral indices like NDVR, NBR. And that works, pretty well for detecting change in overstory vegetation, but it largely fails to capture a lot of what's happening underneath that canopy, particularly in the understory and on the ground. That's a problem because many fires, especially like on surface fires, can burn fairly intensely on the forest floor without causing much visible canopy damage. So the actual severity in terms of ecological impact and fuel consumption oftentimes gets underestimated. And so we wanted to have this study to try to address that gap, and it's to explore whether drone-based photogrammetry, specifically 3D point clouds from multispectral images, could provide a more complete picture of the fire effects throughout the forest. And so we generated detailed models of the vegetation structure. We could not only analyze fire impacts on the different canopy height strata, but also digitally log, like essentially remove all of the overstory vegetation to look at solely the ground, which is captured in those oblique angles from each of the drone images, and opens up the possibility of, accurately assessing fire severity in the understory and ground layer, even in areas where tree crowns would otherwise block the view from above. And so the goal was really to move beyond that flat pixel-based assessment and instead get like sort of a more three-dimensional, vertically stratified view of fire effects.
Yeah, I thought this was a really interesting paper in the fact that we had the Z. We had always had X and Y, but now we got the Z. That's really important in fire severity. So can you tell us about the study and just exactly what did you find?
Yeah, so it was conducted at Fort Jackson in South Carolina. It's an active U.S. Army base. They already have a prescribed fire program there to manage the longleaf pine forest there. And the site was great for a few reasons. The longleaf pine ecosystems, they have like a relatively open canopy, so we're actually able to really capture the understory with those drone images. And that openness allows for that drone's oblique images to get a clear view of the understory ground layer. Also, with that having a prescribed fire program ongoing, we were able to work with the fire crews at the fort and coordinate with them, so we actually had a really controlled environment. We had 7 plots, 5 were test, 2 were control, just to make sure any changes we were detecting were actually because of the fire, not just like some relic of having a pre and post imagery. The results really showed that, unsurprisingly, that the fire had the highest impact on vegetation below 6 meters in height and areas that are often underrepresented in that traditional remote sensing indices. A key outcome was really to be able to, at that 2-meter mark, essentially remove from the three-dimensional point clouds that were derived from the photogrammetry, remove all of the overstory vegetation as if we went in and cut everything down until it's purely at the ground, and get a clear unobstructed view of the surface conditions and classify the ground cover type. Like through 3 centimeter level resolution, classify things of bare soil, leaf litter, woody debris, live vegetation, and post-fire black char, white ash. And our overall accuracy was about 87% of actually just seeing what was in the understory and what what had changed. So what class changed to what? Those unburned control plots gave us that control, so we were able to still do that classification in our control plots, same level of accuracy, but also not categorizing any change as ability for the methods. We also compared the drone-derived NDVI to satellite-based DNDVI from Sentinel-2 and Landsat imagery. And while the satellite imagery definitely detected the change, our plots were about 0.2 hectares each. Definitely had a much smaller level of change as registered than like the understory only imagery that was derived from the drones. And so it's pretty clearly demonstrated that the overstory in the vegetation, the satellite pixels, definitely obscured some of the understory fire effects. This drone-based method really did successfully capture that vertical differences in fire severity. It revealed the fine-scale surface impacts. It's limited in scale compared to what can be covered by a satellite, but it did outperform like the satellite data.
Yeah, I thought a very interesting point of this paper was the fact that this 3D method was able to include causal mechanisms of what drives fire severity and not just give us a sheet of the paper view, but actually look into what drove fire severity and its various components. It was incredibly interesting, and I'm sure the management implications of this paper are pretty vast, right, Jonathan?
Yeah, I think so. It has several impacts, more implications for management. The main contributions might be that fire severity in 3 dimensions, the X, Y, and Z, as you were mentioning it before. It really gives managers a clearer picture of like how fire affected different layers of the vegetation, especially separating that understory from overstory. And also will give managers that ability to digitally remove the overstory vegetation to see on a fine scale, did this burn meet objectives? Like, did it actually reduce fuel surface loads to the desired outcomes? Like, were there pockets within the area of the prescribed burn that weren't burned to a degree that was desired? You're really getting into that classification of that pre and post fire ground conditions. And also, I think there's a really big opportunity here to use this methodology for post fire recovery. We put a fire through, we clear out the understory, and then you're only limited to how often you can fly a drone, I suppose, but you can go back out and see how is the vegetation coming back? What's coming back? What are the species coming back? What is the gaps in distribution of the live vegetation? Like, how rapidly are the fuels building up again, et cetera, et cetera.
I suppose we're not that far away from having this being used on the bear teams after fires, right? I mean, they're probably already using it now, for God's sakes. Well, I want to thank you for taking the time and talking about your paper. Is there any co-authors or funding agencies you'd like to recognize?
Oh, absolutely. First, I'd like to acknowledge all the individuals who are essential to the work. Dr. Andrew Hudak and Akira Kato from U.S. Forest Service and Shiba University in Japan were out on the ground with me, and they provide a lot of mentorship and helped guide the development of the study really from its earliest onset. Also, my committee chair, Dr. Monica Moskal, providing all my guidance at University of Washington, and also Dr. David Weiss for contributions to all of the research design, logistics, and review analysis. I mean, also really important, I think, too, is to acknowledge that the fieldwork and data collection was only possible through the collaboration and team at Fort Jackson, prescribed burning team they have there. And in terms of funding, this project was funded through the Strategic Environmental Research Development Program, SERDEP, as well as U.S. Forest Service, as well as the Precision Forestry Cooperative from University of Washington. It was a very collaborative, interdisciplinary effort, and extremely thankful for the support and expertise of all the folks that were involved.
Well, big shout out to Andy Hudak. Andy Hudak is one of our best associate editors. He gets all the remote sensing ones, so I always like to recognize our associate editors if they are also co-authors on a paper. So thanks, Andy. And thank you, Jonathan, for spending the time with us today. I really appreciate it. Listeners, if you are interested in this paper, as I was, and I went and downloaded it, and you can too, you can download it from the journal's website for free. That's because Jonathan has already paid the freight for you. So he has front-loaded the paper and has said, hey, look, I want people to find out this research for free. And so that's what Fire Ecology is. You can download it and read it at your leisure. So again, Jonathan Batchelor, thank you for coming, and please tune in to the next Fire Ecology Chat.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. FIREECOLOGY.org.